Let us write the embedded C program to interface and control a DC motor. Before proceeding further with the program, let me introduce you the introduction to the DC motor here. So DC motor is a class of rotary electrical motors that converts direct current electrical energy into mechanical energy. Okay, and the basic principle is that whenever a current carrying conductor places in the magnetic field, it experiences a mechanical force. So you can see there are two main parts of the DC motor. Okay, so one is the armature, another is a stator. This is the armature here, this is the armature, and these are the stator. So the rotating part is the armature. So this is the rotating part here. Okay, and the stator is the stationary part, right? So the armature's coil consists of commutator and brushers. So this is the commutator here, this one, and these are the brusher. The commutator converts the AC induces in the armature into DC, and brusher will transfer the current from rotating part of the motor to the stationary external load. Okay, so the armature places between the this north and south pole of the permanent or electromagnet. So let me show you the working of this DC motor. So here you can see that there are two connections in the armature. One is connected to the P0.11, that means port 0 11th pin, another is port 0 8th pin here. Okay, port 0 8th pin. Now the main aim of our experiment is to rotate the motor in anti-clockwise and clockwise, also to switch off the motor. Okay, and there are it is represented using bits here. You can see here, if you put 0 0, the motor will be off. If you put 0 1, the motor will rotate in anti-clockwise. If you put 1 0, the motor will rotate in a clockwise direction. Okay, this is how it is going to work here. Okay, and this is the circuit diagram, and this is the circuit diagram here, and you can see that DC motor, what is there is as an external hardware here. It is connected to the motor driver. Okay, it is connected to the motor driver, L293D motor driver. Okay, and through that driver it is connected to the LPC214 microcontroller from the two pins here, P0.8 and P0.11, port 0 8th pin and port 0 11th pin, the two armatures. You can see 1A and 2A, the two armatures of the DC motor is connected to the LPC214 microcontroller through the driver here. Okay, through the driver, and you can see the one end of the driver is connected to the two power supplies, plus 12 volt and 5 volt, and another end is connected to the ground here. Okay, this is how we can interface a DC motor to the LPC214. Now let me introduce you the GPIO registers which are used in this embedded C program. Okay, the first one is IO0 DIR. So this is a direction register here. DIR stands for direction. Okay, input output 0 port 0 direction pin. Okay, so here we need to ensure whether that port 8 and port 0.8 pin and port 0.11th pin is an output pin or an input pin. Okay, if we consider it as an output pin, you have to make it as 1, and if you want to make it as an input pin, you have to make it as 0. Now in this case, as we had seen in the diagram, that port 0.8 and port 0.11, these are connected to the LPC214, correct? That means output pins. So we have to make it as 1. So how do we do that? Do it as 1. You can see the diagram here. You can see here. So first, see 8th and 11th, right? In the place of that 8th and 11th, we have to make it as 1 and 1. Look at here, 0 0 0 1 2 3 4 5 6 7 8th pin 1, 9 10 11 11th pin 1. Rest all as 0. 32 bit, no, rest all as 0. At that time 0 0 0 0 will become 0 0 0 0 0 1 0 0 1 becomes 9, again 0 0. So IO0 DIR should be set to 0x 0 0 0 0 0 9 0 0. So this is your direction flag here. Okay, similarly we are going to set the clear flag. Okay, now let us go to the IO0 clear. You can see here IO0 CLR. CLR means clear. Okay, again this is again a 32-bit wide register, and this register is used to make the pin 11 and 8 of port 0 low. Okay, if you want to make any pin low, that means if you want to clear, you have to set the pin as 1. Remember this. For clear also, if you want to make anything low, you have to set the pin as 1. If the pin is 1, if in clear flag, if the pin is 1, okay, that means it is 0. If the pin is 0, that means the clear is not set. Right? If you want to clear the pin, you have to make that pin to 1. Okay. So if you write 1 to that specific bit, it makes that pin low. Okay, writing 0 has no effect, because of course if you write 0, the particular GPIO register has no effect. Okay, if you make that pin specific bit as 1, it will make the pin to low. And you can see which pin we have to make to low, that is 8th and 11th pin again. So again it will be in the same fashion. So 0 0 0 0. Okay, this 8th and 11th pin we are making it as 1. So why we are doing this? Because to make it as 0. If it is 0, the motor will be off. Yes or no? The motor should be off. See, you have 3 operations. Okay, once you transfer the code from the processor to the microcontroller, automatically the motor will start rotating. Okay, now to make it as off, you have to clear it. That is 0 0. If you want to make it in clockwise and anti-clockwise, you can use 0 1 or 1 0. Okay, that I am going to show you right now. Now let us go to the another register, that is IO set. Okay, so this is the IO set. So this is GPIO port output set register. Again, this is a 32-bit wide register, and this register is used to make the pins of the port, that is port 0 or port 1, to high. Which of the port you want to make it high, that you can do it. So this IO0 set register will help you in rotating the motor in a clockwise or in anti-clockwise. As I already mentioned you that if you make the port 8 0 and port 11 port 0 11th pin as 1, then the motor will rotate in clockwise. If you make a port 0.8th pin as 1 and port 0.11th pin as 0, then the motor will rotate in anti-clockwise. Okay, now if you want to make it at clockwise, then you make 0 in port 0.8th pin and 1 in place of 11th pin. So this will give you what answer? You see, 0 0 0 0 0 8 0 0. That if you put this value in IO0 set, the motor will rotate in clockwise. Now if you want to make an anti-clockwise, I told only port 0.8th pin to be 1, rest pin everything should be 0. So this will give you the answer 1. So if you have initialize the value 0x 0 0 0 0 0 1 0 0 in IO0 set, then the motor will rotate in anti-clockwise. That's all. So IO0 set register, GPIO port output set register, will help you in rotating the motor in clockwise or anti-clockwise. Okay, similarly direction flag will tell which of the pins has to be made as output pin, that is 8th and 11th pin. IO clear will switch off the motor, so that when you make the bit as 1 in IO0 CLR, automatically the motor will be switched off. So these 3 registers are very important for us to know it. Okay, and also in the program we can see here, we had seen that download the program to ARM kit and connect the DC motor module to FRC1. FRC stands for flat ribbon cable. Okay, we have around 5 flat ribbon slots in the LPC2148 trainer kit. Okay, among which we are using FRC1. Okay, I will show you the diagram for that. Just have a look of this FRC diagram here. Okay, look at here. So we have FRC1, FRC5, okay, FRC3, FRC4. These are all 10 slots. It is having 10 slots. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slots it's had. But except FRC2. FRC2 has 16 slots. It has 16 slots. Okay. Now in our experiment we are making use of FRC1. When we talk about FRC1, one should know the pins associated with the FRC1. You can see here port 0, all are port 0. Okay, you should know this FRC1 pin numbers and description. Port 0, all are port 0, but the pins are starting from 16 to 16, 17, 18, 19, 20, 21, 22, 23. That means it has 10 slots. As you can see here, it has 10 slots. Among 10 slots, it is using the port 0, 16th pin to 23rd pin. The rest 2 pin will be used for VCC power supply and ground. Okay, 9th and 10th pin. Please do remember this one. 16 to 23 we are going to use, because while explaining the program, you should know why that 16th pin is made as 1 or 0. Okay, so in our program totally, actually we are going to consider 16th and 19th pin. Okay, we are going to consider 16th and 19th pin instead of 8th and 11th. For the explanation purpose, I told you this way, right? I had given you this. See, 8th and 11th pin, that armature is connected to the LPC2148. But in our program, we are considering P0.16 and P0.19. And you know what has to be done. If it is 0, 0, off. If it is 1, 0, clockwise. If it is 0, 1, anti-clockwise. Okay, in that way, we are going to run our program. Okay, and you can see this is the LPC2148 trainer kit based on ARM7 architecture. Okay, this one. And you can see this is the microcontroller here. This is the microcontroller. However, during the execution, I am going to show you the LPC2148 trainer kit. Okay, lively. But this is just a top view of the trainer kit. You can see it here. This is the ARM7, okay, LPC2148 microcontroller here. And these are some crystal clocks here. And we have the power cable. Okay, here. These are LED and this is a input jack. And these are some LED bulbs here, and these are the FRCs. You can see here FRC1, FRC1, FRC2, FRC3, FRC4, FRC5. You can see except in FRC2, rest all are having 10 slots. Only in FRC2 we have 16 slots. Okay, and these are UART connectivity. UART 0, UART 1, UART connectivity. Okay, this is the USB through which we are going to connect it to the processor. Okay, this is a serial communication port here. Serial communication. Okay, and these three are switches here. This one PWM, ISP in system programming, and this one. Okay, we have to switch it on so that we can transfer the code from the processor to the controller. Okay, however, I am explaining this again during the execution. Okay, now let us jump on to the program. So in the program, you can see the first line is the header file, that is lpc214x.h we have to include, and of course we have three functions to be declared. One is to clockwise, anti-clockwise, and delay. Okay, now in the main function you can see IO0 dir equal to 0x00090000. I hope all of you understood this. Okay, direction flag, what does it indicate? That means it is indicating that 16th and 19th pin I am going to make it as output pin. Look at here, guys. Okay, see here, this 0 will represent 0 to 3, correct? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now 16th pin, 16, 17, 18, 19, that is 1, 0, 0, 1. Correct? Now 16th and 19th pin I made it as a 1. That's the reason we have got 9 here. Rest all are 0. So direction pin will ensure which of the pins are output pin or input pin. Okay, so this is done. Next is IO0 set. So by default I am going to set it to the anti-clockwise, and I told you 16th and 19th pin should be 0 and 1. 0, 1 means 19th pin should be 0, 16th pin should be 1. If it is there, then of course it will the motor will rotate by default in anti-clockwise. Okay, so this is this number is for 16 to 19, correct? 16, 17, 18, 19, right? 16th pin is 1, 17, 18, 19 is 0, 0, 0. So 0, 0, 0, 1 will give you 1. Okay, so that is why we are set it to this one. So you can also change it to 9, 0 also. So that means by default it will work with the clockwise. It is up to you. Okay, then I am going with the while loop here. So this will continuously rotate the DC motor, right? So you can use while loop, and the first function I am going to call this clockwise. Let me take you to the clockwise function here. The return type is void, it does not return any value. Now what do you see here? First I need to clear it, because the motor is rotating. See, at the first time the motor was rotating in anti-clockwise, right? Now clear it so that motor will be off, and give some delay of 100 milliseconds and set it to 0x00080000. I hope all of you understood why did I wrote 8 here. IO set. Hope you can see in IO set we had got this value, right? So now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you have to set it now, whether to clockwise. Clockwise is 1, 0. So this will be 1 and this will be 0. Okay. So this will give you what answer? 8. So that is what I wrote it here. 0008 0000. So we had set it. So if I place this value in IO0 set, that means we had set to the clockwise direction. The rotor will rotate in the clockwise direction. Similarly, you can use the anti-clockwise functions here. Again, I will clear it. Okay, so to clear, I need to make it as 9. That means both the pins has to be set to 1. It will give you 9. Okay, then after a small delay, again set it to 0 1. So 0 1 also I mentioned you earlier. Okay, you can see it here, 0 1. Here they had made it to 8th and 11th pin. We are making it to 16th and 19th. That's all. Okay, so that will give you this answer, and that you load it in a IO0 set. So mainly IO0 set is used to ensure whether the motor is rotating in clockwise or anti-clockwise. So 0x001 0000 will rotate, will help the motor to rotate in anti-clockwise. 0x008 0000 will make the motor to rotate in a clockwise. That's all. And after that we have a small delay where we had declared two variables I and j, and we had used two for loops so that it will take some time to do this operation. Okay, and after that it will again move on to the set and reset. Okay, because we had used while loop, no, here while loop, right? We had used while loop here. Okay, it will keep on, motor will keep on rotating. Okay. Now let us move on to the execution part of this program.
Let me introduce the ARM7 LPC2148 trainer kit. ARM stands for Advanced Risk Machines, LPC Low Power Consumption 2148. Okay, so this LPC2148 is a type of microcontroller which is using the ARM7 cores. So first of all, let me give you a brief introduction to all the different parts of the LPC2148 microcontroller. So as you can see here, so this is the device of LPC2148 from NXP. So this is the microcontroller here. Okay, and you can see this is a quad flat microcontroller, because in each side of the microcontroller there are 16 pins. So altogether we have 64 pins. Okay, and you can see this one. So this is the 12 megahertz crystal oscillator device speed. And you can see here, so this is 32.768 kilohertz crystal oscillator for RTC clock. And here this is VREF. So this is a jumper setting for ADC external voltage reference. So you can see here this one. This is a 5 volt red LED indication, this one. Similarly, you can see here just below that, this is 3v3 green LED indication. Okay, and this is the battery, this one. Battery for RTC backup running. And this one is the power on or off switch. Okay, so whenever you give the 9 volt DC power supply, this is a switch here to switch it on or off. And this is the input power jack. This is the input power jack. This is the input switch for external interrupt. Okay, so this is a switch here, on and off. Okay, so this is the input switch for external interrupt, and this is the input switch for reset the device, resetting the device, input switch. Okay, similarly we have two UART cables here. So this is the UART 1 connectivity, and this is the UART 0 connectivity. So UART stands for universal asynchronous receiver and transmitter. Okay, and these are the LEDs for PWM output. There is an LED here. Okay, this stands for LEDs for PWM output, and this is the PWM enable switch. Okay, this is a switch here. Okay, on and off. Yes, and this is the USB connector for ISP programming and serial port connectivity. So this is where we need to plug in the serial interface cable. okay, so that we can boot the program from the processor to the microcontroller. Okay, and these are the LED indication. This is used to confirm the USB connection has been established successfully or not, right? And this is the switch selection. These two are the switch selection. So this is used for switch selection for ISP or UART. So the selection will be for ISP if the switch has been pressed, else it will be for UART. Okay, so this is a switch for on and off. Similarly, this is the switch for to enable the ISP. So both are for ISP. This is for PWM. Okay, and these are all the FRCs. You can see there are 5 FRCs: FRC1, FRC2, FRC3, FRC4, and FRC5. Okay, in this except FRC2, rest all are having 10 pins. FRC2 is having 16 pins. So here, this is the IO port 10 pin FRC connector for FRC5. This is for FRC4 10 pin. This is for FRC3 10 pin. This is having a 16 pin, as I mentioned you, that is FRC2, and this is for FRC1 10 pin. This is the LPC2148 device daughter card. Okay, and you can see here, this is the USB ISP programmer daughter card. So this is the serial interface cable. Okay, so one end we are connecting it to the UART slot here. Okay, in this way, right? And other end USB, this is connected to the processor. This is how we can be able to boot the programming from the processor to the microcontroller. This is the FRC cable. These two are FRC cable, flat ribbon cable. Okay, so you can see there are 10 pin flat ribbon cable. As I mentioned you, for FRC1, FRC3, FRC4 and FRC5 we use this cable. Okay, similarly this is a 16 pin FRC cable. 16 pin. This is used only for FRC2. And this is the DC power supply of 9 volt and 2 amplifier. Okay, and this is the input jack to which we are going to connect it to the LPC2148. Okay, so LPC2148 trainer kit, we are connecting this to this input jack. So now, as you can see that the serial interface cable is connected to the processor, and from that we have connected it to the UART slot here. Okay, and once it is successfully connected, you can see the indication there, LED indication. This will tell the successfully establishment of the serial interface cable to the UART slot. As well as you can see the power cable here. These are the two LEDs which is going to tell us whether the power is switched on or not. Okay. So now let us see the execution of a DC motor. So here we are going to interface and control a DC motor to the LPC2148 microcontroller. Okay. As you can see, this is the FRC cable, flat ribbon cable. Okay. And you can see in the LPC2148, we have 5 types of FRC cables here. Okay, FRC1, FRC2, FRC3, FRC4 and FRC5. Among which FRC2 has 16 pins, FRC1, FRC3, FRC4 and FRC5 has a 10 pin. So okay, so we need to connect the DC motor module to the FRC1. Okay, so this is the FRC cable here. Okay, now one end has to be connected to the FRC1 of LPC2148. Okay, so we have to connect to here, and other end to the DC motor. This is the DC motor. This is the DC motor. This is the motor, and this is the driver through which we can communicate to with the microcontroller. Okay, so other end has to be connected to the DC motor. So after doing this, we have to connect the DC power supply 9 volt and the serial interface cable. Okay, switch on the power supply. You can see these two LED lights glowing when you switch on the DC power supply of 9 volt, and here two UART 0 and UART 1 UART slots has to be switched on, and this has to be switched off. You can see here PWM has to be switched off, and other two has to be switched on. Okay, ensure that the serial interface cable is properly connected to the LPC2148. You can see the green color LED is glowing there. Okay, once you do the setup, we have to write the program. As you can see that I written the program as I explained you earlier. After this, it's the same procedure. What we need to do is we have to add this to the target group here. You can see I had already added it, DC motor.c. After that, we have to compile the program. You can see 0 errors, and later on we have to build the program. Okay, once we build the program, it's time to burn the program to the microcontroller. For that we required Flash Magic software. Please select the device LPC2148 with the COM4 9600 baud rate. Okay, and the oscillator megahertz is 12. After that, you have to browse for that particular hex file. So it is here DC motor.hex file. Open it, and you have to click on start so that we can burn the program to the microcontroller. So as you can see that it's verifying, and you can see the DC motor is working here. Can you see here? Okay, it is rotating in a clockwise as well as the anti-clockwise direction based on the program written. Thank you.